we talk a little bit about the phage lethal agents. So this is a genetically modified phage. It infects the cells and unable to recruit progeny. So you can have it express a lethal protein after infection, or you can just have a defective phage. Now, I'm not going to talk too much about this because there are exactly 2 papers that I can find on this technology. One of them uses a defective phage, the other one has the phage delivering a protein which is lethal to cell upon expression. And they've done a little bit of mouse work and they've shown some efficacy. The potential advantage for this is that you don't have, because the cells don't lyse, they just die. Right? This is the important distinction between a regular phage life cycle where you have the cell actually burst open, releasing progeny and releasing all the cell wall contents. These cells are just big. The lethal agent is expressed inside the cell, the cell remains intact. And because this happens, you don't have this large release of endotoxin. And so if the mouse that you're treating has a large load of bacteria, you won't get the same kind of toxin shock effect that you would see with lysine. And lastly is the phage lysine. So this is been built by a couple of places, but really it's a Vince Fischetti of Rockefeller kind of owns this field. And it started with the isolation of the endolysin from streptococcal phage and purification and expression of this lysine by itself. Now this works really well against gram-positive bacteria. So gram-positive cells have the peptide glycan exposed. And so these are, they have several papers on doing this in mice. They have also isolated aside from streptococcal lysins. They also have one for bacillus anthracis. And this is for people who don't spend all their days worrying about what the cell wall bacteria looks like. You have a gram-positive cell which has a peptide glycan here on the outside that's exposed. And you have a single membrane here. So gram-negatives which have the peptide glycan sandwiched between an inner and outer membrane, this strategy doesn't work very well. There's one paper where they actually have isolated phage lysine, and they claim that they put a lot of it in, they will get some killing or some growth inhibition against gram-negative cells. But it's certainly nothing like what you see with what you can see in gram-positive, because the target of that enzyme is exposed right out here on the surface, and they really need this to live. If you have a hole in it, the turgor pressure inside the cell will cause the membrane to stream out. This is from the paper on the bacillus anthracis lysine, and so this is after 0 minutes, 1 minute after lysine exposure. You can see the cells rounding up. So the cells here are these long filaments. After 1 minute, they start to round up. After 15 minutes, they're kind of disintegrating. And these are some really nice EM pictures where you can actually see. So the lysine has drilled a little hole through the peptide glycan of the cell wall, and you can see the cytoplasmic contents starting to stream out of the cell. And then after a few minutes, I believe this is after 1 minute, you can see the cells look very kind of granular, and it's falling apart. There's like some intermembrane debris down here. Okay, that's kind of it for the therapeutic part of the talk. Yes.
For the wiki, I guess I'll put it on the wiki, but Shelley has a video. I don't know if you've all seen it.
Yeah.
Showing cells die and all.
So you tell me the one where he's holding up the tube?
Yep.
Yeah, so I don't have a copy of that actual video, but if you can put it up, that would be really good.
Well, I mean, I can put a link up.
Yeah.
But also Betty Cutter.
Mm-hmm.
And Evergreen is a real good place to look for the Russian stuff. Just for,
Yeah.
Interest for the students.
Oh, absolutely. Well, if you want to get the good history, there's a couple of articles. There's one from William Summers from 1999, and there's a book that came out. It's Betty Cutter and Sulek Melitze's book, Bacteriophage Biology and Applications. It has a chapter in there about phage therapy in humans. And Betty Cutter, she's really close with the Georgians who are actually doing this work. And also Sulek Melitze is he's a Russian speaker. So they have a really good review about the history, and they talk more about the Russian experience and the Georgian experience in phage therapy. It's an interesting story. There's a Romulator. I can put all that stuff up and give you the citation. Okay.
Has anybody tried to make a phage that modifies the bacteria so that it's more susceptible to the immune system?
Not that I'm aware of. There has been a little bit of work actually looking at phages. If they're effective with the phage, they actually become more susceptible to antibiotics. possibly through cell wall leakage. But I'm not aware of that. Although if you could get a phage actually to attach to the cell, you have the opportunity to kill it right then rather than worry about the immune system taking care of it though. So, I can see there might be applications that would be useful though, but I'm not aware of anybody doing that. Yeah.
It seems like you're pretty well read on this stuff. I was just wondering if you come across any cases where people have tried to use bacterioses, which are basically like phage tails. Some bacteria are known to express the killer editors, and any better or worse or different successes you've seen with that approach.
That's just a very common question. So one of our research collaborators actually had just isolated a bacteriocin.
Can you repeat the timely question
Oh,
for us?
sorry. So the question was, are there any, has anybody done any work with bacteriocins, which are proteins released by bacteria which will pretty much kill the neighbors essentially. So there's two kinds. There's the kind of bacteriocin which is essentially a phage tail, and there's another which is a small molecule, like a colicin type bacteriocin. So I'm not aware about using colicins. There is, like I was saying, one of our collaborators actually has isolated one of these phage tail-like bacteriocins, which actually we'll probably start looking at in mice for treating peripheral malaria. So method is often very slow. Sometimes 1 to 7 days to get positive results from culture methods. You're